Hi, I'm YUMIN Primary 6 from YUMIN Primary School. For this time, we are still continuing with ordinary differential equations. For ordinary differential equations, we'll learn many different types of methods and how do we use different methods together for one example. And we'll find all these by exemplification. So let's take a look at the example we have here. Meanwhile, I'll write this down. This example is 2y prime prime minus 5y prime minus 12y. And this is equal to sine x. So we have this kind of example. Let's first check what type of ordinary differential equation this is. Firstly, this is linear. It's constant coefficient. Well, non-homogeneous ordinary differential equation. And this is second derivative. Since this is a non-homogeneous and we want a general solution for non-homogeneous differential equation, that means we can split it into the general solution for homogeneous differential equation and particular solution for non-homogeneous differential equations. So in short, we write as YG equals YH plus YP. So we have first find for YH. Okay, YH. That means you'll first let this part be equal to 0. Then at this part, we can let y be e to the power of lambda x. So we let y be e to the power of lambda x. Then that means e to the power of lambda x can be simplified from all these. So that means you get this. Now we can find what is this lambda. So to find this lambda, we can find it by using the cross multiplication. So this part using the cross multiplication. Okay, so we get this part. So this is 2 lambda plus 3 times lambda minus 4. That means this first root, so we can say this part would be negative 3 over 2. Then for the second root, it's 4. So that means that this part, the homogeneous solution would be C1 e to the power of negative 3 over 2x plus C2 e to the power of 4x. So right now here we can start finding for YP, the particular solution for non-homogeneous differential equations. So YP here, we will need to first let. So what do we let here? We only need YP be something. But we have to look at this part. So sine x might come from cosine x or even just itself. So we're not sure how much of sine x and how much of cosine x are there. So we just use A and B to represent this. So here is A sine x plus B cosine x. Then first derivative, A cosine x minus b sine x. Okay, then after that we find the second derivative. So here you have negative a sine x minus b cosine x. The next step is just to put all these inside this equation. And all this adds up to be sine x. So right now we can say that we are going to use the coefficient comparison, or comparison of coefficient, or determine the coefficients. Let's first take a look at sine x. Sine x, you have negative 2a, you have 5b, and you have negative 12a. So that means negative 14a and 5b. This will be 1. Then after that is cosine, negative 2b, negative 5a, and negative 12b. So that means right now here it is like this. Okay, so what can you put for this part? So at this part, what if we move this to the other side? Okay, let's try. So that means 5a would be negative 14b. And a will be negative 14 over 5b. So then we can start this inside. So that means b would be 5 over 2 to 1. That we can sub this back to find a. So a would be negative 14 over 2 to 1, like this. So now we found a and b. We can sub them back into here to find yp. So yp would be like this. After that, you add both of these to find yg. So when you write it, it's like this. So this is your answer. So that means for this part, it will just be, okay, let's take a look at this process. So in this process, the first part is we change it from the general solution for, well, this, what type is it? Well, as At the beginning, I told you this first U, linear, then constant coefficient, non-homogeneous, ordinary differential equations. So then this part is a general solution for non-homogeneous differential equations. So we split it into this general solution for homogeneous differential equation and particular solution for non-homogeneous differential equation. So that means we split it into two separate. Then for this homogeneous part, we use the characteristic equations. But for these characteristic equations, it must be homogeneous, linear, and constant coefficients. Well, for these characteristic equations, you let y be this e to the power of lambda x. Well, what if it is sine and all those others? Well, it's just e to the power of the thing is the best. Okay, so for this lesson, I think I can end it here. So if you like our videos, don't forget to subscribe to our channel. So we'll see you in the next lesson and thank you for your watching.